Hey everybody, this is just a screencast so you know how to make your data tables and do your calculations in Excel for your acid-base titration lab. So first off, here I have Microsoft Excel open. I've zoomed in so you can kind of see what I'm doing. This is what the data tables look like in your procedure. And what I want to do is I want to just try to make my data tables resemble those. Since I have a good starting point, might as well use it, right? And so you can see I have mass, initial, final, volume. So here's mass, initial, final, and volume. So to be more precise, volume of titrant, in this case it's going to be sodium hydroxide, delivered, delivered, and that's going to be in milliliters, so I should put those units. This is going to be my final volume of sodium hydroxide. That's going to be in milliliters. And this is going to be my initial volume of sodium hydroxide in milliliters. And I guess I could just put sodium hydroxide delivered milliliters, make it shorter, because milliliters we can assume volume. And I could also just take out the volume of for these as well, be a little bit leaner with my table. So now I have initial sodium hydroxide, final sodium hydroxide, delivered, all in milliliters. You can see that the contents of the cells are wider than the cell is. So what I could do is I could go up here and I can click and drag to change my cell size. What's nice about Excel is I could just double click and it will automatically adjust that cell size. Going up here, I have mass of my acetic acid. Instead, I could just say, no, this isn't acetic acid yet. This is oxalic acid. And that's going to be in grams. And let's see how we're doing. So we have mass of acid, initial volume, final volume. Then I'm going to have my molarity, or sodium hydroxide concentration, which is a molarity, so I put my units of moles per liter. There we go. Make my table a little bit bigger. Okay, let's get some data in here. I'm going to take some data from a student's lab that had taken this or done this lab years ago, and I'm going to copy and paste it right there. It kept the formatting, so I'm going to strip it of the formatting by going to clear formats. Here we go. So it's just the numbers. You could see that they didn't do a good job reading their burette. So I'm just going to make up some extra digits for them because they screwed up. And while I'm doing this, well, I can't multitask, I guess, but here we go. And what you'll notice is that you saw me type in that 0.00. Anytime something comes up in Excel and it's 0.00, it doesn't want to keep those zeros there. And what you could do to deliberately put those extra digits that Excel thinks are superfluous, you could click on the cell and go up here in your number settings. And if I want to change them, I can go increase decimal or decrease decimal. In this case, I'm going to increase my decimal. I just want 2 places after the decimal point, as if I was reading the burette in actuality. So now I have my raw data for oxalic acid. Let's see. I will copy and paste his oxalic acid data. And to be honest, I actually copied and pasted the wrong data. This data I'm going to use later. That's what they used for their vinegar analysis. And so let's pull their hydroxide data. And that's right here. Okay. Get rid of the formats. There we go. And again, same thing with the decimal points. They screwed up. So I'm going to just pretend this is what they had instead of what they wrote by error. There we go. So now we have some more realistic data. So this would be raw data. I have my oxalic acid masses, trial 1, 2, and 3. I have my initial volumes, 1, 2, and 3, and final 1, 2, and 3. You might just have 2 trials. You might have 5 trials. That's fine. As many trials as you did, you should make that many columns. You saw me just insert this row up here because I'm going to put some header rows in here. So if you right-click on the row number, you can click on Insert, and it's going to insert a row at the top. I want to label these trial 1, trial 2, and for a fun fact, since these have counting numbers in here, if I select both of them and click and drag, it'll automatically fix the numbers so that they keep on going in order. I just have 3 trials, so I'll get rid of this data. Okay, so I'm ultimately trying to figure out my sodium hydroxide concentration, and once I do that for 3 times, I'm going to average it. And so I could even put an average column over here. There we go. And these are calculated values. And what I do not want to do is I do not want to take my calculator and start calculating the answers and then typing them in. And once we get to finishing this, I'll explain why it is extremely beneficial to type and calculate in Excel rather than just transposing from a notebook. Excel is a lot more than just a nice table builder. It's actually a calculation mechanism. So in order to get the sodium hydroxide molarity, I'm going to need to find the moles of sodium hydroxide. So let's insert a column for my moles of sodium hydroxide. And it's just going to be moles. And in order to get moles of sodium hydroxide, I'm going to need moles of oxalic acid. So let's insert a row here. And I'm going to put oxalic acid and then change my grams to moles. There we go. And I can calculate this information. So my moles of oxalic acid can be determined by using the masses that I used and the molar mass that we know for oxalic acid. We used oxalic acid in its dihydrate form, which has a molarity of 126.07. So 126.07. And in order, you'll notice one thing is I put this equal sign. Whenever you're going to do a calculation in Excel, you're going to start off by putting an equal sign. That lets Excel know that it says, hey, I'm about to do a calculation, and treat it as such. So I have my equal sign, and to calculate the moles from molar mass, I need to take my mass and I need to divide it by the molar mass. So I have the molar mass there, and so I'm just going to click on my mass. So it says B2, and I'm going to put a slash for division so that it has B2, which is actually this cell right here, and it's going to divide it by the molar mass of 126.07. I clicked on the cell B2 so that if I later decide that 0.32 is an error, a mistake, and maybe it was 0.34, I can fix it. And once I hit enter, watch for the oxalic acid moles to readjust. It automatically fixes that cell. And so that way I wouldn't have to go back through and change a lot of things. I would just change it one place and it fixes it elsewhere. I'm also noticing that these oxalic acid values aren't very precise, so we'll fix these quick by making up some more data, because that's what I do. Just kidding. So yeah, I have my oxalic acid moles there. And here comes the power of Excel. So Once I have one calculation done, if I have a bunch of repeated calculations, just like I dragged the trials over and it automatically populated those numbers, I could click on this cell, I could click on this little green box until I get the black crosshairs, click and drag over, and it's automatically going to readjust that B2, which is the oxalic acid mass, to the next trial over as I drag it over. And that's very convenient because I only have to type formula once and then just click and drag. Done. You'll notice that my oxalic acid moles, I'm getting 4 sig figs when I should start with 3. So I could readjust my numbers. I went the wrong way. There we go. I readjusted my numbers so there's 3 sig figs. And now I have moles of oxalic acid. If you were to write the neutralization equation for oxalic acid reacting with sodium hydroxide, you will find that the molar ratio between the two is that you will need to have 2 moles of sodium hydroxide for every 1 mole of oxalic acid. Knowing that, if I use the stoichiometric ratio and I take the moles of oxalic acid, so equals moles of oxalic acid times 2, I will then get the moles of the sodium hydroxide. Enter. There we go. There's my moles of sodium hydroxide. Change my sig figs so it's correct. I always go the wrong way there. And now I can get the molarity of my sodium hydroxide if I divide it by the volume of sodium hydroxide that I used. Well, to determine the volume of the sodium hydroxide that I used, I'm just going to make a formula here for sodium hydroxide delivered equals, and then the total delivered is going to be the final minus the initial. So in this case, 27.29 milliliters were delivered. Click, drag over. You could see it automatically moves the cells that are being used over as I clicked and dragged it over. And now I'm ready to calculate my sodium hydroxide concentration. In order to do this, it's going to be, so the equation is molarity is equal to moles divided by volume in liters. So equals, here's my moles of sodium hydroxide. Here's my volume of sodium hydroxide. Note, this is in milliliters. I need it to be in liters. So I need to convert my B6 value, my milliliter value, to liters. So to convert a milliliter value to a liter value, I need to divide it by 1,000. There we go. Left parenthesis, right parenthesis, make sure that my order of operations is going to be fulfilled. Enter, it solves. And as your lab states, the sodium hydroxide was supposed to be 0.2. You could see that we're a little short here, which is fine. That's the whole reason why we are standardizing the sodium hydroxide, is to figure out exactly what the sodium hydroxide molarity is, so we could use it to calculate the molarity of the vinegar, or the acetic acid in the vinegar. So since I did this calculation, I can click and drag it over, and I have my 3 molarities. These should also have 3 sig figs, because I used mass up here to find the moles of oxalic acid, so 3 to 3 moles of oxalic acid to the moles of sodium hydroxide. I multiplied it by a value of 2, which is a integer value. It's a counting number, so it has infinite sig figs. So my moles of sodium hydroxide should also have 3 sig figs. And then I multiplied, or I divided my moles of sodium hydroxide, which has 3 sig figs, and divided by these volumes that have 4. Well, it's limiting by the moles limit the sig figs to 3, so here are my 3 values. Now I'm moving on to my average column. In order to average these 3 values here, all I need to do, well, I could do it one of 2 ways. I could make a formula knowing how to calculate an average, so I could hit equals and then do B8 plus C8, and you'll note that you could actually type in the letters rather than just click on them if you would like it or think that's faster. Right parenthesis, divide by the number that I have. I have 3 of them. Enter, there's my average. A quicker way is to just use the stored average calculation formula in Excel. So I hit equals, or yeah, I type equals, and then I type out the word average. And then you could see that it shows me all these different formulas that are similar to that. I just want the first one. Once I start the left parenthesis, it gives me directions on what to do next. Well, I'm going to do my numbers. I could either click, comma, click, and do it that way. Or I could simply just click and drag. Either way, I'm going to get the same answer. And it's going to be 0.190. That's my average. If this had too many sig figs, I'd have to adjust it. So I can see my average molarity for my sodium hydroxide here is 0.19 molar, 190 molar. And I need to do a similar calculation for my analysis of vinegar. So let me pull open the lab. So I have volume of vinegar, initial volume of sodium hydroxide, final volume of sodium hydroxide delivered, and then my molarity of the acetic acid. So I'm going to need these three columns. I could put them here. I'm going to, actually I need another, at least another. And here, this is going to be the, here is going to be the acetic, or the vinegar volume. How do you spell vinegar? Okay, there we go. There's the vinegar, and you're going to plug, or you're going to, this is the volume of vinegar, so it's going to be in milliliters. We pipetted the vinegar so that it's exactly 5.00 milliliters. That is, if you're a good pipetter, we're going to assume that you are. So this should be the same, so copy, paste, there we go. Make it more sig figs. Perfect. For my data, I already pulled that earlier. Move it up. I cut and pasted. So you can cut and paste stuff wherever you want just by selecting. And then I do Control X, but you could also use the button up here. Click and then Control V, or use the button here. Paste, and it's going to move it around. So I could quickly select and move data. So there is my vinegar titration data that I pulled from an older student's lab. And I'll close your lab over here. Okay. Sodium hydroxide delivered. Well, that's the same calculation as up here. So I could either retype the calculation of final minus initial, done, or since I did that same calculation up here, I could just copy and paste it. You could see that it uses the same calculations. It uses proximity pasting, which means for this calculation up here, it used the cell above it, subtracted from the cell and it subtracted the cell that was 2 above it. Well, if I copy and paste that down here, it does the same thing. It subtracts the cell that's 2 above the cell above it. And so it automatically adjusts those values. So there's my sodium hydroxide delivered. I'm ultimately trying to find out the mass percent, or you can say the concentration of vinegar, or the concentration of acetic acid in vinegar, and that's going to be percent by mass. So I should actually say percent weight by weight is how you would actually write that. And adjust my column size by double clicking. And before that, I'm going to need my concentration of acetic acid in vinegar in molarity, because that's part of the lab as well. So moles divided by liters. There you go. So those are the things that I'm looking for. So in order to calculate this, I'm going to need moles. So I'm going to add a column for acetic acid moles. Keep on forgetting the word acid. There you go. Acetic acid moles. And that has to be calculated. And once I have that, I can divide it by the volume of acetic acid up here, convert it to liters, and I have my concentration of acetic acid. I'm also going to have an average, so I can actually pull that calculation from up here, because I'm going to use that. It says # div/0 exclamation point. Divide by 0. So that means divide by 0 error, which, because if I average these three and divide it by the number of things I have, well, it's going to be 0. So 0 plus 0 plus 0 divided by 0, it's going to be divided by 0 error. So that's why it's saying that. But once I fill in data, it will automatically fix that. That's not my actual data though. For my acetic acid moles, in order to calculate that, I need to first figure out the moles of sodium hydroxide. And so I did that earlier up here. You can see that was calculated from the moles of oxalic acid. I'm going to have to calculate that in a different fashion down here. And I could do that from my sodium hydroxide concentration. So my sodium hydroxide concentration is going to be used with the volume delivered. So molarity times volume in liters is going to be concentration, or it's going to be the number of moles. So I'm going to take my molarity, M, times my volume, V. I need to convert that to liters. There you go. So I have molarity times volume in liters, and that's going to give me my moles. It's going to be a very small amount of moles. So there are my 3 sig figs, because I have 4 for the volume, 3 for the molarity up here. So that's that's the moles of sodium. The moles of sodium hydroxide. I'm going to deliberately make a mistake to show you how to correct something. So I'm going to click and drag. Oops, these are 0. Why are they 0? Well, here you could see that I used this piece of data in B13, and I used this piece of data in E8. But as I dragged it to the right, what Excel does is it drags this cell up here, my concentration, to the right. But since I'm using an average value, I don't expect that to change as I drag across. Okay, and so what I need to do is I need to fix that so that it's highlighting the data that I want to use rather than an empty cell. To make sure that doesn't happen, you can go through and see how it says E8. If you put dollar signs in front of the column and the row, that locks that cell reference into place. So once I hit enter and drag it over, now it's going to keep on piloting that same E8 cell as I drag it over. But since I didn't do the dollar signs with the other one, it goes from B to C to D as I drag it over. Okay, so I have moles of sodium hydroxide. If you do the titration neutralization reaction for sodium hydroxide and acetic acid, you'll find that it's a 1-to-1 molar ratio. So this times 1, or you don't have to put the 1, is going to be the same. Adjust my sig figs so something shows up. There we go. And so for the concentration of acetic acid, I need moles divided by liters. Well, my volume is 5 milliliters, so it's going to be my moles divided by my volume used, converted to liters, of course. There you go. Drag it over. Perfect. And there's my concentration of acetic acid. And that looks, I honestly can't remember what it's supposed to be, but it must be good. So 3 sig figs. So there's my average, 0.812. For my concentration of acetic acid, this is kind of the central calculation associated with this lab, so I'm not going to give it away, but I expect you to do the calculations here in Excel. So now that we have our Excel made, I'm going to tidy it up. So right now it's just raw input. I want to make this look like a legit, nicely formatted table. So first of all of this information here, I want to have centered. So if I select it all and I click Center Justified, it will center everything. Over here, this kind of looks sloppy, so if I right justify that, it'll look a little bit better. If I bold all of my row headers and column headers, so I'm selecting and doing a Control B, or you could hit this button up here. And there you go. So that's a little bit better. If you wanted to, you could move the part 2 and part 1 side by side rather than top and bottom. And well, actually, I'd have to move down a row. So I have room for my headers. Copy and paste my headers. Control C, Control V, and there you go. It's kind of hard to tell the difference between part 1 and part 2. So what I could do is add another header row, and I could write what's going on. So this first part, I'm doing a standardization. So standard neutralization of sodium hydroxide. And over here I have an analysis of vinegar. There you go. I can bold those, so I selected both of them. I can select multiple cells by holding down the control button and just clicking on multiple cells, and it selects all of those. So I want to select this one and this one, make it bold, control B. And it will look a little bit nicer if I take this whole thing. So I'm using columns A through E here. So if I select these 5 cells and I hit this button, merge and center, what it does is it merges those cells and it centers the contents of the cell. There you go. So now this is all one cell. I can do that over here. And this is all one cell as well. I think it looks better when it's top bottom rather than side by side. So I will move that over there. So if I were to print this as is, this is what it's going to look like. Not much of a table because it doesn't have the outlines. So to add the outlines, you go to Home, and it's this button here. And there's a variety of options. You could do no border, or not outlines, but borders. You could do no border, you could do all borders, you could just do outside, you could do a thick outside border, you could do custom borders, okay, you could do all kinds of things. A real quick thing to do is just to select one table at a time and just do all borders. Select everything, do all borders. And that way you could see what's going on. Everything's a little bit more organized and it looks a little bit better. Okay, so there is my data table in Excel. Now I'm going to show you how to go one step further and import this and embed it into Microsoft Word so you don't have to do a copy, paste, screenshot type deal into your Word document. I missed a column down here, so I'm going to select it and do all borders again. There we go. Don't forget to calculate this. So calculate the concentration of acetic acid from your average. Or you ultimately want the average of this, however you decide to do it. Okay, so I'm going to save this book. So File, Save As. I'm going to put it right on my desktop so I could find it. I can keep it as book 1 because it's just a sample. So let's say I'm writing my lab report. And I get to my data and calculations section of my lab report. And I am ready to put that here. In order to do that, what I could do is go to Insert, go all the way over here to Text, and there's this little box, white on the bottom and it's blue on top. That's the object icon. If I do a drop down and I do Object, or actually you could just click right on the icon, Object, and I want to create from File because I saved my Excel file and I want to embed that in this document. So when I hit Browse, find my document, so desktop, here it is, and I want to make sure these are unchecked because I don't want to just link it in, because if I hit link or display as icon, so I'll show you how this works. So if I insert it as a link file, oh, that's surprising. I thought it was going to show a link. If I insert it as a icon, oh man, there you go. It's just going to have a link in there, and you can double click and it'll open the file. I don't want that. I want to embed it. So I'm going to go to Insert, click there, create from File, make sure this is unchecked. Find it once again. Boom. Okay. It's going to embed, or it's going to try to embed my information. It didn't do a very good job. I'm not too impressed here. Let me try closing this and see if it, maybe it is saved weirdly. Let me try that one more time. I shouldn't have said one more time because it's going to be multiple times now. Hey, there we go. Okay, so it was trying to embed a temporary file because I still had the document open. So I closed it, I saved it, I closed it, and then now it's going to work. So what that did is it imported exactly what I made it in Excel. So what the program is doing is it's going in and it's looking at that file that I said to import, and it's choosing whatever's in the open spreadsheet. So in Microsoft Excel, you could have multiple sheets. Whatever sheet is open, it's going to import the contents of that sheet. So let's say you use this much stuff, it's going to say, okay, this is the table that they want to embed. I'm going to put it there. Perfect. And so now you have a table embedded in your Word. And you might say to yourself, oh, well, what's the point of that? Why couldn't I just take a screenshot and import it or paste it in there? Well, the reason why is because this is still an active Excel file when I double click. So maybe I'm at the end of my lab, I printed it out, and I'm comparing to my lab partner or something, and I noticed that I made a typo. My initial sodium hydroxide value, instead of 0.6, it was supposed to be 0.4. Well, that changes a lot of things about this lab. So I could do a double click in here. Instead of 0.6, it's 0.40. And watch how everything is going to change, because the initial sodium hydroxide changes the volume delivered, which also changes this molarity, which changes the average, which down here changes a lot of these calculations as well. So when I hit enter, everything self-fixes. When I click out, good as new, perfect. But I do see that I lost the top title. So I have analysis of vinegar here. I had standardization of sodium hydroxide at the top. For whatever reason, that got lost. So maybe I need to, some programs have allow you to reset it. It's not letting me. I'm just going to re-import it. So object, create from file, browse, desktop, book one. There you go. Anyways, so yeah, that's what you want. And I think this, is this what I changed it to? I think it is. So yeah, that's how you make a table in Excel. That's how you use Excel for calculations. That's how you import stuff from one Microsoft program to another one. Very handy, very valuable information. Once you get good at using Excel, you become extremely efficient with calculations. You become extremely efficient with making reports and working with spreadsheets. I hope this is helpful to you. If it's not, shoot me an email and I will help you out.